Dear students, welcome back to the HS second year Commercial Mathematics and Statistics class. আমি ইয়াৰ ক্লাছবোৰত ইয়াৰ আগৰ ক্লাছবোৰত আমি arithmetic mean, median আৰু modeৰ definition, formula আৰু mathematical applicationৰ বিষয়ে পঢ়িলো আৰু যিমান ধৰণৰ problems আহিব পাৰে পৰীক্ষাত বা আমাৰ কোৰ্সত আছে সেইখিনি আমি ডিসকাস কৰিছো আজি এই শ্ৰেণীটোত আমি এটা নতুন ধৰণৰ প্ৰবলেম যেটো আমি প্ৰ্যাকটিক্যালি কিতিয়াবা ফেস কৰিব পাৰো আৰু সেই প্ৰবলেমটো আমাৰ arithmetic meanৰ লগত জড়িত আৰু সেই প্ৰবলেমটো আমি কেনেকৈ সহজে সলভ কৰিব পাৰো তাৰে বিষয়ে আমি কথা পাতিম কিতিয়াবা এনেকুৱা হ'ব পাৰে যে আমাৰ হাতত 10টা অবজাৰভেশনৰ arithmetic mean দিয়া আছে অৰ্থাৎ we have supposing some values x1 x2 etc to ami dhori lusu x10 leke 10 ta observationer value kisuman dia ase logote arithmetic mean to dia ase ta mane arithmetic mean etu eta ami discrete series etar kothai koisu orthat arithmetic mean dia ase mane 1/n summation x a formula to apply kori where n is the number of observations ami a formula to use kori a observation khinir arithmetic mean to amar hatot dia ase ei gute keta observationer value to amar hatot na thakibo pare kintu pisot ami gom palu je ei 10tar bhitorot ji kono eta ba duta ba tinta variable or value to ami hunute bhul hol ba likhute bhul hol ba launte bhul hol it might be such that we had taken one or some of the values of the variable wrongly all right then what happens this x bar or this arithmetic mean will be called the incorrect x bar or incorrect arithmetic mean because some of the values were taken wrongly one or more values in that case instead of now when our aim will be to find the correct x bar that means our aim will be to find correct arithmetic mean to find the correct arithmetic mean we do not have to take again all the values of the variable x find its summation and then divide by n that is the that will be a tedious process যেটু কাম অলরেডি আমি কৰি থৈছো আমি সামেশন উলিয়াই থৈছো এটা বা দুটা ভ্যালু ভুল হোৱাৰ কাৰণে আমি কিহৰ বাবে আকৌ আমি সামেশন x2 উলিয়াম all right is a summation x2 ami uliaisilu with the wrong observations this is the incorrect summation x all right oshuddha summation x itia amar kam hobo je ami correct mean uliam aru correct mean uliabo karone ami correct summation x a incorrect or pora amar ki kam hobo we have to find out correct summation x all right if we know correct summation x and then divide the correct summation s by the total number of observations we will get the corrected mean or the correct x bar that is x bar is equal to correct summation x divided by n where correct summation x is equal to incorrect summation x যেটো আমাৰ ভুল টোটাল আছিল তাৰ পৰা আমি মাইনাস wrong observation বা observations হ'ব পাৰে যদি এটাতকে বেছি হয় যিমান কেটা অশুদ্ধ observation আছে হেকেটা আমি মাইনাস কৰিম প্লাস correct observation or correct observations এটা আছে যদি আমি এটা প্লাস কৰিম এটাতকে যদি বেছি দুটা বা তিনটা আছে হে গুটে কেটা আমি প্লাছ কৰিম অৰ্থাৎ যেটো ভুল টোটাল আছে হে টোটালৰ পৰা আমি ৰং অবজাৰভেশন খিনি মাইনাস কৰিম কাৰেক্ট অবজাৰভেশন খিনি এড কৰিম কৰাৰ লগে লগে আমি কাৰেক্ট সামেশন x পাম এই কাৰেক্ট সামেশন x টু যেটি আমি ইয়াত বহাই দিম আৰু নাম্বাৰ অফ অবজাৰভেশনছ ৰে আমি ডিভাইড কৰি পেলাম আমি কি পাই যাম আমাৰ কাৰেক্টেড x bar যেটো আমাৰ ইনকাৰেক্ট হৈ আছিল because of wrong entry yes that will become corrected so let us discuss a small sum related to this problem the mean of 20 observations was found to be 25 later on it was found that one of the observations one of the observation 15 was misread as 50 find the correct mean find the correct mean all right so by reading the question what we understand is what is given to us yes what is given to us n is given to be 20 number of observations what is 25 25 is the mean of 20 observations but by reading the entire question we understand that it is the incorrect mean so incorrect x bar is 25 all right and now what is the next information given later on it was found that one of the observation 15 was misread as 50 tamane wrong observation to ki wrong observation hol 50 ami 50 boli lolu kintu hobo lagisile 15 correct observation to hol 15 ekhini information amak dia ase itia this is given to us all right now to find ami ki uliabo lage to find correct x bar this is our problem we have to find correct x bar for correct x bar as we know that correct x bar is equal to correct summation x divided by n all right now amak dia ase incorrect x bar is equal to 25 n is equal to 20 all right therefore incorrect total to kiman hobo incorrect summation x karon amar x bar or formula hol 1 by n summation x therefore what is summation x this is n times x bar so if we multiply n into x bar we will get the incorrect summation x all right now from this incorrect summation x we can find the correct summation x is equal to incorrect summation x minus wrong observation plus correct observation. So our incorrect summation x is 500 minus 50 plus 15 will give us 465. So once we know the correct summation x, we can easily find the value for, we could have marked this as equation 1. Yes, so therefore equation 1 implies correct summation, correct x bar is equal to, correct summation x value is 465 divided by 20 will give us 23.25 units will be the correct value for the mean, which was wrongly found to be 25 when one of the observation was wrongly taken. Sometimes again it might be such that instead of one wrong observation, you might have more than one wrong observation, and in that case what we do is we subtract all of them, it might be 2 or 3, and then add the corrected items, and the other procedure remains the same, and we at last, making use of this formula, we can find the corrected x bar. Alright, so you just take down one more question which you can do on your own. The mean of 200 observations, the mean of 200 observations was found to be 50, was found to be 50. Later on it was found that two of the observations were misread as 92 and 8 instead of 192 and 88. Find the correct mean. Find the correct mean. Yes, in this case, instead of one wrong observation, you have two wrong observations, 92 and 8. These are the wrong entries. 192 and 88 are the correct entries. Alright, or correct observations. So what you have to do, you have to follow the same procedure. Instead of just subtracting 1, you will subtract these 2, and while adding, you will add these 2 to get the correct summation x, and when you divide by total number of observations, which is 200, you will get the corrected mean. So this sum you can do on your own. The answer should come to be 50.9 units. Alright, so please try to do it for yourself. So dear students, with this we come to the end of arithmetic mean, median and mode problems. 2 more measures are left. Mathematical measures, I think you remember, total we had 5. 3 we have already discussed. First was arithmetic mean, which is a mathematical measure. Second, we discussed median and mode. Third is mode, which are positional measures. We go back to the mathematical measures now. The first one we shall take up is geometric mean. Gunattor Madhya. Alright, geometric mean. So first of all, the definition of geometric mean. Alright, geometric mean, you may write down the definition. In short, we call it GM. Geometric mean may be defined as the nth root of the product of nth root of the product of n observations of a series. Alright, nth root, you know, a root. So we have to take the nth root of what? Of the product of the observations given to us. If we are given two observations, we will find the product of two observations and find the square root. If we have three observations, we will find the product of three observations given and then find the cube root. If you have four observations, you will have to find the product of four observations and find the fourth root. Alright. So in general, if x is a variable which take values x1, x2, etc. up to xn, yes, how do we define geometric mean? Geometric mean will be the product of all these observations, x1 into x2, etc. up to xn, and then you find the nth root. Alright, so this is the basic definition of geometric mean. And geometric mean, it is denoted by the letter G. G will denote geometric mean. Just like x bar denotes arithmetic mean, M denotes median, Z denotes mode, geometric mean will be denoted by G. So again, we shall take up the formula for geometric mean for the three different kind of series, that is discrete, non-frequency distribution, discrete frequency distribution, as well as grouped frequency distribution. So let us take them up one by one. Prothomote ami loisu discrete non-frequency distribution. Orthat frequency dia jodi nathake titia hole amar গুণাত্তৰ মাধ্যৰ ফৰ্মুলাটো কি ধৰণে আমি লিখিম। So যদি non frequency distribution হয় তেতিয়া হলে we will consider the values of the variables as x1, x2, etc. up to xn. আমি ধৰি লৈছো যে x চলকটোৰ n টা ভ্যালু দিয়া আছে, then geometric mean, which we will denote by G, as I've already told, is the product of x1, x2, etc. up to xn whole to the power 1 by n, and its root of the product of all the items. But you see, if you have 2 or 3 or 4 items, it is fine. We can multiply and then find the required root. It might be square root, cube root, or the fourth root. But if the number of observations or the values of the variates given are very large, then what happens? Finding the product of a large number of items and then finding the root, say the 10th root or the 20th root will indeed, or say 30th root, will indeed become a very, very tedious task as far as calculation is concerned. Orthat, jodi amar jimanta value dia ase x or hetu jodi besi hoy, মান বেশি হব পারে, number of observations বেশি হব পারে, if this n is very, very large, তেতিয়া হলে কি হব, আমার এই ফর্মুলা ডাইরেক্টলি অঙ্ক কৰাটো দিগদাৰি কঠিন হৈ পৰিব। তেতিয়া আমি কি কৰিম, আমি লগ লৈ পেলাই আমি geometric mean define koribole chesta korim. Supposing this is equation 1. All right, taking logarithm, taking log on both sides of 1, but taking log of equation 1, we have log g is equal to log of x1 into x2 into etc. up to xn whole to the power 1 by n. So log hole amar ki hobo, the power becomes product, so this will become 1 by n, aro product bur ki hoy jay log lole plus hoy jabo, addition hoy jabo, so this will become log of x1 plus log of x2 etc. up to log of xn. In short, we can write this as 1 by n summation log x. This is log g. Okay, so log g amak na lage, amak lage g. Ami calculation hohos koribo karone he log loisilo. So we have to find g, which will be the geometric mean. What will be g? G will be anti-log of 1 by n summation log x. So this is the formula for calculating geometric mean in case of a discrete non-frequency distribution. By use of logarithm, we will make our calculations easier. All right. Next, we shall take up the discrete frequency distribution. So if we are considering a frequency distribution, distribution kon dekhat kenekwa hobo, so along with the given values of x, some frequencies will also be associated such that summation of all the frequencies is denoted by capital N. We already know what is a discrete frequency distribution. In this case, how will we define geometric mean? Geometric mean G is equal to x1 to the power f1 into x2 to the power f2 into x3 to the power f3 all product xn to the power fn whole to the power 1 by capital N. All the larger calculation. Yes, every x, every value of x raised to the power of its frequency, raised to the frequency implies raised to the power of number of times it occurs. You have to find the product of all these values and then find the root 1 by n to the power 1 by n, that is we are finding the nth root, capital nth root, where capital N is nothing but summation of x. It might be 50, it might be 100, or it might be more than that sometimes, but a large number indeed. So again we shall make use of logarithm to make our calculations easier. So this is equation number 2. So in this case, when we take log of equation 2, we have log g is equal to, when we take log, what will happen? All these powers will become product, these products will become addition, and this power will also become a product. So this will be 1 by n f1 times log of x1 plus f2 times log of x2 plus etc. up to fn times log of xn. So in short, this can be written as log G is equal to 1 by n summation f times log of x. But we require G, we do not require log G. G is the geometric mean. So what will be G? G will be the anti-log of this value. So anti-log of 1 by capital N summation f log of x, where capital N is summation of the frequencies given. So this is the formula for calculating geometric mean in case of a discrete frequency distribution. Next comes the grouped frequency distribution. The grouped frequency distribution, that is when discrete values of the variable x are not given to us, but some class intervals, inclusive or exclusive, whatever, might be given to us. And how are we going to find the geometric mean in that case? So the formula will be same. Now class interval and frequency is given. What we have to do, just like previously we had discussed, we have to find out the mid values. X represents the mid values, and then the formula will remain same. G is equal to anti-log of, just like the formula for discrete frequency, anti-log of 1 by n summation f times log of x. And what is this x? X is the mid value of the class intervals given to us. So with the same formula we can find out the geometric mean for a grouped frequency distribution also. I think the three formulae are clear to you. Now students, here I would like to mention that as far as exams are concerned, you get geometric distribution sums only for discrete series, discrete non-frequency distribution. Otherwise you usually do not get such type of sums, but I will just show you the type of tables you have to draw, and you can practice your sums from different books you have. Okay, so if you have a discrete series, so we have the three formula for a discrete non-frequency series. If supposing only 2 or 3 values are given, you can directly multiply and then find the geometric mean by finding the necessary root. Alright, but if you have more values given to you, then you have to make use of logarithm. For discrete non-frequency distribution, the table will be like this. You just check how the table looks like. Alright. Only x will be given to you. You find out log x. Yes, looking into the log table, you will find all the, supposing the values are 2, 3, 4, 5, 6. Alright, you will find the value for log 2, log 3, log 4, log 5 and log 6. Alright, so you will find these values at the end of the table. You will find summation log x and put it in your formula, G equal to anti-log of 1 by n summation log x. Alright, log x you already have. You divide log x by the number of observations given to you. Here the number of observations is 2, 3, 4, 5. So n will be 5. You will divide this value by 5. Whatever you get, you will take the anti-log of that particular value. Okay. If you have a discrete frequency distribution, যদি x or লগত f দিয়া আছে তেতিয়া হলে আমি কি কৰিম আমাৰ টেবলখন দেখাত কেনেকুৱা হ'ব আমি ইয়াতে log x উলিয়াম প্ৰত্যেকটো log x ক আমি f এৰে মাল্টিপ্লাই কৰিম supposing this is log 2 log 3 and so on আৰু ইয়াতে frequency ধৰক দিয়া আছে 3 4 5 7 10 all right so every log value will be multiplied by the respective frequency and you put the values here and you find the summation for f log x okay and here you will find what is n and then by using the formula g equal to antilog of 1 by capital N summation f log x you can find the geometric mean summation f log x you will find from here you multiply you divide by the total frequency you will get this value within the bracket you find antilog of this value by using the antilog table you will get the required value for g similarly if you have a grouped frequency distribution class intervals will be given to you you find out the mid values and then follow the same procedure this is how you calculate geometric mean for 3 different kinds of data set that is discrete non-frequency discrete frequency and grouped frequency distribution here it is important for all of us to understand the uses or the merits of geometric mean so just like all other measures of central tendency whatever we have learned up to now geometric mean is also rigidly defined it is based on all the observations it is suitable for further algebraic treatment it is very less affected by extreme values and it is a very suitable measure for finding ratios percentages rates etc okay these are the merits but there is a demerit also here the calculation does not seem to be very easy for a huge data set where the number of observations are very large or the values of the varied values are large or the frequencies are large it becomes a very tedious process and the use of logarithm and the log table sometimes makes it difficult for learners to understand this is a demerit of geometric mean but it has got very wide application in social science in economics etc where for construction of index numbers we make use of geometric mean it is very important index numbers are calculated for prices for quantities etc and it is the economic barometer so construction of index numbers make use of geometric mean to a great extent so these are some of the uses of geometric mean so we shall just do a small example type of sum that comes in your exam a very easy sum find geometric mean 2 and 8 অকল দুটা ভ্যালু দিয়া আছে এনেকুৱা যেটা দুটা ভ্যালু দিয়া থাকে আমি লগাৰিথম ইউজ নকৰাকেও কৰিব পাৰো we know that আমি ডাইৰেক্ট ফৰ্মুলা যদি লিখো we know that g equal to 2 into 8 to the power 1 by 2 ta mane square root lole hobo that is g is equal to square root of 16 which will be equal to 4 all right supposing you have 3 values 2 8 and 8 all right then what will be the geometric mean geometric mean will be 2 into 8 into 8 All right. So let us take 3 different values, 2, 4 and 8. Okay, 2, 4 and 8. So how much will be? It will be to the power 1 by 3. That is, we are to find the cube root because there are 3 number of observations. So this is 4 2s are 8, 8 8s are 64, and its cube root will be how much? 4. Find the geometric mean for the following: 50, 72, 54, 82 and 93. You see, number of observations are 5, that is fine, but the figures are very huge and you are not given calculators. Yes, so in this sum we shall make use of logarithm and try to solve it. We know that you write down the formula using logarithm. We know that G is equal to, this is a discrete non-frequency series, so anti-log of 1 by n summation log of x. Okay, so as I had shown you earlier, we shall draw this table. This is x, and here we will find out log of x. All right, you write down the values 50, 72, 54, 82 and 93. Below you will have, as usual, the total column. Here you will find out summation log x. You will find the value for log x, means for the first case it is log of 50. Find from the log table. Similarly, log of 72. Find all these values, add them up, divide it by n, find the antilog, you will get the required value of GM. So log of 50 is 1.6990, log of 72 is 1.8573, log of 54 is 1.7324, log of 82 is 1.9138, and log of 93 is 1.9685, and the total summation log x comes to around 9.1710. So what we have to do is, supposing this is equation 1, if we put this value here, we will get G is equal to anti-log of 9.1710 divided by 5, that is anti-log of 1.8342, and this, when you look into the anti-log table, it comes to around 68.26 units. So this is how we calculate geometric mean from a discrete series. So let us take up harmonic mean. অসমীয়াত আমি হাৰাত্মক মাধ্য বুলি কওঁ। So how do we define harmonic mean? Harmonic mean may be defined as the reciprocal. Okay, I'm underlining this word reciprocal. Is defined as the reciprocal of the arithmetic mean. I am underlining the word arithmetic mean also. Reciprocal of the arithmetic mean of the reciprocals of the observations. Yes, so please try to look another reciprocal. harmonic mean may be defined as the reciprocal. We know what is a reciprocal, the multiplicative inverse. It is the reciprocal of the arithmetic mean of the reciprocal of the observation. Ami kihor arithmetic mean lom? Jodi amak variable bur dia ase x1, x2, variable values bur hol x1, x2, etc. up to xn. Tare reciprocal ki hobo 1 by x1, 1 by x2, etc. up to 1 by xn. A item khinir, a reciprocal khinir ami arithmetic mean lom. Arithmetic mean lom mane ki korim? Ami a item burok plus korim, add korim, and we will divide by the number of observations. Tamane this plus etc. up to 1 by xn add kori ami jodi n ere divide koru, we will get the arithmetic mean of the reciprocal. Aru ei gotei bostu khinir jetia ami multiplicative inverse ba reciprocal to lom, what will we get? We will get the harmonic mean for the given series. All right, so it is denoted by our harmonic mean ami in short ami hm boli denote koriso aru ami jetia ami mathematically likhim ami h boli denote korim. Thik ase? When we have a discrete non-frequency distribution, we are given just the values of the variable x without any frequency being mentioned, then harmonic mean hm will be denoted by h. And what is it? It is the reciprocal. Jehetu reciprocal boli ase, ami prothomote 1 by likhelom. 1 by what? Reciprocal of the arithmetic mean of the reciprocal of the items. Tamane 1 by n of 1 by x1 plus 1 by x2 plus etc. up to 1 by xn. So on simplification an to ami upor likhibo paru, this comes to summation 1 by x. All right, this is the formula for finding harmonic mean in case of a discrete non-frequency distribution. All right, in case of a discrete frequency distribution, if we are given a discrete frequency distribution, that is along with the varied values of x are associated some frequencies f1, f2, etc. up to fn, such that summation f is equal to capital N. Ami janu arithmetic meanor formula to ki asile 1 by summation 1 by capital N summation of f. So here what will be the formula for harmonic mean? This is 1 by jehetu reciprocal shobdo to ase ami 1 by likhilom, tar pisot ami arithmetic mean of the reciprocal of the items tamane kenekwa hobo 1 by capital N f1 times 1 by x1 plus f2 times 1 by x2 plus etc. up to fn times 1 by xn. Okay, and this can be written as capital N by summation f by x. This is the formula for finding harmonic mean in case of a discrete frequency distribution. For a group frequency distribution also, the formula remains the same. For the grouped frequency distribution, the formula will be the same. Only thing is that what is x? Formula will be same. H is equal to capital N by summation f by x. All right. Now what is this x? Because in case of a group frequency distribution, x is not mentioned. Class interval and frequencies are given to us. We find out x, which is nothing but the mid values. So here we shall mention where x are the mid values of the class intervals given to us. Otherwise, formula for discrete frequency distribution and group frequency distribution is the same. Okay, this is the formula for calculating harmonic mean. Find harmonic mean. Wages দিয়া আছে per day. Okay, wages are given as in rupees দিছে, in rupees দিয়া আছে. Rupees 5 তাৰপিছত দিয়া আছে 8 10 15 আৰু 24. So this is a discrete non-frequency series. So the formula will be, we have harmonic mean equal to n by summation of 1 by x. All right. So what is n? Here is 1, 2, 3, 4, 5. Number of observations is 5. So 5 by, this is 1 by 5 plus 1 by 8 plus 1 by 10 plus 1 by 15 plus 1 by 24. You find the value and then it comes out to be to around 9.38 rupees 9.38, which is the harmonic mean for the required data set. All right. A man travels from one place to another a distance of 100 kilometers at an average speed of 20 kilometer per hour. He then makes his return journey at an average speed of 30 kilometer per hour. What is his average speed? What is his average speed in the entire journey? All right. So a man, he travels from a point A, say, to another point B. Jaunte teor A pora B loi jaunte teor speed to asile 20 kilometer per hour. Ako B pa A le jitia ghuri ahise titia teor speed to asil 30 kilometer per hour. Eta average speed uliabo dise. Thik ase? Eta bostu monot rakhiba. Please try to remember when the distance covered is same. A pora B le joa aru B pora A le joa distance to eta. Jetia eta distance beleg speedot cover hoy, we make use of harmonic mean. ঠিক আছে? কিন্তু যদি এনেকুৱা হয় যে এৰ পৰা বি লে গৈছে এটো ডিসটেন্স টু হল 10 কিলোমিটাৰ at some given speed kiba ta speed dia ase say 30 kilometer per hour speed ot goise b pora c leke say this is 80 kilometer hetu eta belek speed ot goise say 40 kilometer per hour speed ot goise enekwa jodi onko hoy jot distances are different then we make use of arithmetic mean. Please try to understand this technicality. Titia hole jitu ami mean average speed ba mean speed pam that will be a very representative value. Ami etu mane jikonote harmonic ba arithmetic mean uliale uttor eta pam kintu besi representative besi proper kitia hobo jetia eketa distance or karone jetia ami varying speed or kotha porhim ami harmonic mean use korim aru jetia belek distance thakibo titia hale aru speed belek thakibo titia ami arithmetic mean bebohar korim. So if we take up this sum you see therefore to find average speed we make use of harmonic mean. Therefore required speed ki hobo n by summation 1 by x yate n ki amar duta speed dia ase so it is 2 eta speed hol 20 so 1 by 20 plus 1 by 30 whatever you get I think it comes to 24 kilometer per hour will be the required average speed of the entire journey. With this definition, formulae and application of the various measures of central tendency comes to an end. And just like the other measures, harmonic mean is also very rigidly defined. It is based on all the observations. It is not much affected by extreme values. But the demerit is that its calculation is sometimes very tedious because finding the reciprocals become a very tedious job. So its use is sometimes limited because of this purpose. Alright, so with this all the 5 measures have been learned and now it is time to know the relationship that exists between the 3 mathematical measures, that is between arithmetic mean, geometric mean and harmonic mean. Very important relationship. All right, there are 2 relationships. The first relationship says that arithmetic mean into harmonic mean is equal to geometric mean square. All right, or it can sometimes be given as root over arithmetic mean into harmonic mean is equal to geometric mean. This is the first relationship. The second relationship says that arithmetic mean is greater than equal to geometric mean is greater than equal to harmonic mean. Tar mane to enekwa je jodi amak eta series dia thake be it discrete be it continuous be it frequency be it non frequency ki hobo jo arithmetic mean or value to hoday sobotke dangor hobo majot thakibo geometric mean or value ar tar pisot thakibo harmonic mean or value tane orthat ei statement to duta bostu humai ase eta hol je arithmetic mean is greater than geometric mean is greater than harmonic mean. Arithmetic mean hoday dangor hobo tar pisot geometric mean or value ahibo tar pisot harmonic mean to logote kintu ami equal to sign eta atao diso equal to kitia hobo so arithmetic mean geometric mean আৰু harmonic mean সমানো হ'ব পাৰে কেতিয়াবা কিতিয়া সমান হ'ব যদি গুটেই কেটা আইটেম গুটেই কেটা observation equal হয় if all the observations taken are equal then the arithmetic mean geometric mean and harmonic mean will coincide all right so you should know the proofs of this too you can go through your books but what is more important is sums relating to these two relationships so let us take up two sums the harmonic mean arithmetic mean and GM of a set of 5 observations are দিয়া আছে আমি স্টেটমেন্ট এনেকে লিখিছো প্ৰশ্নটোৰ যে harmonic mean geometric mean আৰু arithmetic mean দিয়া আছে harmonic mean দিয়া আছে 10.2 geometric mean দিয়া আছে 14 আৰু arithmetic mean দিয়া আছে 16 comment on the statement Tane is the statement correct is this situation correct তেতিয়াহলে আমি কি চাব লাগিব যে এই যে ভ্যালু কেটা দিয়া আছে আমাৰ যেটো ৰিলেশন আছিলে am greater than gm greater than hm এটো satisfy কৰিছে নে নাই am আছে আমাৰ 16 gm আছে 14 আৰু hm 10.2 so since this is satisfied yes so we may say that the given statement is correct আমি লিখিব লাগিব the given statement is correct sometimes you might get sums like this find arithmetic mean geometric mean and harmonic mean observation keta dia ase 2 4 6 8 and hence show that am is greater than gm is greater than hm so this is a very simple question actually where you have to find out the arithmetic mean yes you find in solution first you will find out the arithmetic mean which you will get by adding these values you find out the geometric mean which you will get by multiplying these values and taking the fourth root and then you find the harmonic mean which you will get by making use of this relation and obviously these values that you will find will satisfy this relationship so and there is another type of sum I'm reading out a question the arithmetic mean and geometric mean of two observations are 9 and 7.2 you get this kind of sum also find the two observations and also the arithmetic mean kitiaba observation duta uliabole die ami observation duta a aru b dhori loi palai by forming equations we can find the values of a and b as well as the harmonic mean or geometric mean or arithmetic mean whichever is required to find so this is about the relationship which exists between the three means between the three mathematical averages arithmetic mean geometric mean and harmonic mean so with this discussion we come to the end of the first unit from statistics part of CMST course of HS second year ekhinite ami amar prothom jitu statistics or porihonkha part 2 jikhini amar first chapter ot asile ami gutei khini discuss korilu it is now on the students to go through their books and question papers and prepare for their exams. Thank you so much.